In this video, I'm going to talk about the dependent events and the conditional probability. Okay, let's first discuss about the dependent events. When the outcome of occurrence of the first event affects the outcome of the occurrence of the second event in such a way that the probability is changed, the events are said to be dependent events. Okay, for example, suppose you pick a card from a pack of 52 cards. Suppose there are 52 cards. Okay, and you pick one first. So what is the probability that it is an ace? It is, there are total 4 aces divided by the total number of cards is 52, right? Okay, suppose you do not replace it back, you do not replace the first card back. Okay, if the first one is ace, what is the probability that the second one is ace? Let's write on that a1 is the first one is ace. The probability that the first card is ace is 4 over 52. The probability that the second card is also ace. Okay, what is the probability that the second card is also ace? Given that the first card is ace and it is not replaced back. If you keep that the first card outside, now how many cards left? There will be 51 cards left, right? And suppose the first one is ace. So what is the probability? How many ace left? There will be 3 ace left and there are 51 total cards left. So the probability that the second card is ace is given by 3 over 51. And we are assuming that the first card picked is ace and it is not replaced back. So how do we write that? How do you write that thing is, here what we say is the first card ace is 4 over 52. The probability that the second card is ace given that the first card is also ace. This is what that slash symbol we call given that. Okay, it is called the conditional probability because it talks about the probability, it is finding the probability of the second card ace under the condition that the first card is also ace. I said A1 is the first card is ace. Okay, the probability that the second card is ace given that the first card is also ace is 3 over 51 because you did not replace back the first card in the deck and you are just picking one card out of 51 cards where there are just 3 aces left because the first card is ace and it is kept outside. Okay, so this is called conditional probability. We will discuss that later, but the events, the picking the first card and not replacing back and picking the second card, these two events are dependent because the probability of ace is changed in the first trial and the second trial because we did not keep the ace back into the deck. Okay, so these type of events are called dependent events where the probability of the first event changes the probability of the second event. Okay, all right, in that case what is the probability that of A and B is probability of A times probability of B given A. In this case, in the same example that I just discussed, if you are interested to find out both of the cards are A, then how do you find out that? Is probability that the first card is A and then times probability that the second card is A. But here the first card is not replaced back, right? So let's write on the first card is A and probability of second card given that the first card is also A. So you multiply that way. Okay, so the first card is S is 4 over 52, but if it is not replaced back, the second card is S is 3 over 51 and you multiply to find out the probability. Okay, this is the AND rule or the product rule when the events are dependent. If the events are not dependent, if you replace it back, then it would be just PA1 times PA2. But if you don't replace back, then you write PA1 times PA2, second card is S, given the first card is S and not replaced back. This is how we denote that. Okay, this is the notation. See the formula? When two events are dependent, the probability of both occurring is PA and B, where PA times PB given A is already happened in the first trial. Okay, PB given A, it is called conditional probability, but you can think of probability of B given that A already happened. Okay, this is how you call for this probability. Okay, let us see some examples. A card is drawn from a deck and not replaced. So it is dependent, right? It is not replaced. So there will be just 51 cards if you draw one card and not replace. Not deep. So I'm sorry, the events are dependent because the first card is picked, drawn, and then it is not replaced back. and then the second card is drawn, find the probability of getting both queen. What does that mean? That means probability of Q1 and Q and Q. You can write this as probability of Q and Q, right? This is the product rule. You see that? Because it is, you want to find out both queen. So what does that mean? That means the first one must be queen times the second one must be also queen, given that the first one is queen and not replaced back. So what is the probability that the first one is queen? How many queens are there in a pack, in a deck of 52 cards? 4 out of 52, right? Times, what is the probability that the second card is queen, given that the first card is queen and not replaced? That will be just 3 queen left, and then there are just 51 cards left. So if you multiply these together, what do you get? You need to use calculator for 0.0045. 0.0045. So this is unlikely, right? What does that mean? Meaning that if you pick one card from a pack of 52 cards, and if it does not, if you don't replace back, and if you pick the second card, the probability that both the first and second are queen is 0.0045. It is less than 1%, right? So it is unlikely. How about both spade? So probability that the spade and spade, that is probability of the first card is spade and the second card is spade. You can write like that, right? So that means probability that the first card is space is S1 times probability that the second card is space, given that the first card is already spade and not replaced, because it is not replaced, right? So how many spade are there? 13 out of 52 times, if you don't replace, then how many spade left is 12 out of 51. You just multiply, you get 0.0588. 0.0588. So 5.88%, right? So this is likely to happen, but it is low probability. So what is the third question asked here? The third question says that both of them of the same suit. What does that mean? That means probability of both of same suit, meaning both must be spade spade or club club or heart heart or diamond diamond. That's what it is saying, right? Probability of SS plus probability of HH, right? Heart heart plus probability of diamond diamond, right? Plus probability of club club. That's what it is asking. So you are not replacing back. So probability of SS, we found that already, right? So it is 13 over 52 for the first spade, and you don't replace back, so the second one will have probability 12 over 51 plus. Now the heart is also the same thing, right? If you pick the first one, is heart is 13 over 52 times the second one is 12 over 51 plus. For the diamond, the same story, 13 over 52 times 12 over 51, and then plus, and this one is also 13 over 52, both club. The first one is club is 13 over 52, and then second one is club is 12 over 51. Okay, so if you use calculator to find out all these, then you will get basically 0.2353. 0.2353, that is 23.53%, which is same as 4 times that, right? 4 times that, because they all are of the same suit, either spade spade, both, or both heart heart, or both diamond diamond, or both club club. This is how we find out. Okay, all right, the last one is one club and one diamond. So what is the probability that the one is club and the other is diamond? How do you do that? Is probability of one club and one diamond, right? So what is the, so there are two possibilities for that. So probability of the first card is club and second is diamond, right? Plus probability of first card is diamond. Let me write that the first card is diamond and the second card is club, right? So C2. So how do we find out this? It's the same thing. So probability of C1 times probability of D2, given that the first one is C1, plus probability of D1 times probability of C2, given that the first one is D1. You can write that way. Okay, so what is the probability of the club? The first card is club, that is 13 over 52. Now what is the probability that the second card is diamond, given that the first card is club? How many diamond are left? The first one is club already, right? How many diamond left? 13 diamond left, but there is 51 in total because you did not replace back. Plus, similar case here, 13 over 52, the first card is diamond, is 13 over 52, and then so the second case is, the second card is club, given that the first card is diamond, 13 over 51. Okay, so you multiply so these two and that two and then add together. What do you get? Let me find 0.6372 for each of them, and then if you add them, then you will get 0.1275. So you will get 0.1275 if you use your calculator. Okay, this is how you find out the one club and one diamond. All right, so let us do example number 6. The worldwide insurance company found that 53% of the residents of a city had homeowners insurance. So what is the if you pick one person, then what is the probability that he has the homeowners insurance is 0.53. Of these clients, you are picking from those clients that has homeowners insurance. Okay, 27% also had automobile insurance. What is the probability that the person selected has an automobile insurance, given that he is picked from the homeowners insurance group? Okay, what is given that is 0.27. So if a resident is selected at random, find the probability that the resident has both homeowners and the automobile. What is the probability here? Is probability of H and A. The formula is probability of H and then times probability of A given H, right? So what is the probability of H? 0.53. It is given here. And what is the probability of A given H? Is 0.27. If you multiply those two, you will get 0.1431. So 0.1431. Okay, so basically this is the probability of the person. If you select a person randomly, then the probability that the person has both homeowners and the automobile insurance is 14.31%. That's what it means. Okay, let's do another example. That should be example number 7, I think. This should be example number 7. So let me write down that 7, and the other one will be just 8. Okay, so this should be example number 7. What does it say? Box 1 contains 2 red balls and 1 blue balls. Let me box 1. Okay, this is B1. How many red balls? 2 red balls and 1 blue balls. And then box 2 contains 3 blue balls and 1 red ball. Okay, this is box 2. Okay, box 2, and then 3 blue balls and 1 red ball, 3 blue ball. A ball is selected at random from a box. So you don't know which box you are taking. Okay, you randomly select a box and randomly select a ball, and find the probability of selecting a red ball. So you want to find out the probability of selecting a red ball. So that red ball could be from box 1 or red ball could be from box 2. Okay, so how do I find out the red ball? You can do pick the first box and then find the red ball from box 1, right? And then plus you can do the pick the second box, right, times probability of red ball from the, given that it is from the second box. Okay, what is the probability of the first box? There are just 2 boxes, right? So probability of the picking first box is 1/2 because there are just 2 boxes and you are picking the first box, that is 1/2 times probability of red ball from the first box. What is the, how many red balls are there? 2. How many total balls are there? 3. So probability of red ball in the first box, right, is basically 2 out of 3. So you write 2 out of 3 plus probability of second box is 1/2 again times probability of red ball in the second box is basically 1 out of 4 because there are total 4 balls and there is only 1 red ball. Now what you do is you basically add these two or simplify those two numbers. Okay, so you get, what is your final? Your final answer is 0.4583. 0.4583. Okay, so this is the solution of that problem. So if there are 2 or 3 boxes, then you need to pick the box. Every time you need to pick the box and then find the probability of a certain color of the ball inside each of the box, and you add the probability. If you draw the tree diagram, what do you get? So there is a box 1 and then box 2, right? And in the box 1 there is 2 red ball and then 1 blue ball, right? And in box 2 you have so how many blue balls? So in the box 2 you have 1 red ball, let me write down so 3 blue ball and then 1 red ball, right? So you want to select a ball. So you select a ball means you need to first select the box, right? From box 1 and box 2. What is the probability in the red ball on the box 1? That is the probability of box 1 times probability of red ball from box 1 and probability of box 2 times probability of red ball from box 2. You need to find the probability of this and then probability of that. Probability of this plus probability of this and probability of that. And then if you add them together, then you will get that value. Let us do this example, okay? Oh, I think we did the similar example already here. Actually, example number 5 is exactly same as the example number 8. Okay, 2 cards are selected from a standard deck of 52 cards without replacement. It says without replacement. So exactly the same situation. Find the probability that both are of the same color. What does that mean? Both same color means not the shoot. The color and shoot are the different, right? There are 26 cards of red color and 26 black color card, but the suit there are 4 suits: diamond and then heart and then club and spade. They are called the suit. So here, how do you do that? Probability of the first card red times probability of second card red, given that the first card is red already. Okay, plus similarly here, probability of black and black, right? The same color means red or black. So probability of first card is black times probability of second card black, given that the first card is black. So how do you find out that? What is the probability of red? Is 26 over 52 times probability of second card is red, given that the first card is red, is 25 over 51, plus the same thing, right? So black is 26 over 52, the first black card, and the second black card, given the first card is black, is 25 over 51. You just use calculator and you get the final answer there. Similarly, both are diamonds. How do you find out both are diamonds? Both are diamonds means basically it is probability of the first diamond times probability of the second card is diamond, given that the first card is also diamond, right? So how do you do that? The first card diamond is 13 out of 52 times the second is diamond, given the first card is diamond, is 12 out of 51. You just use calculator and multiply that. Here also similar thing, right? Because we did exactly similar example there. So this is diamond and diamond is given there, and for spade and spade we have the same expression. For club and club you will have same expression, and the heart and heart you will have the same expression, and you add them together. All right, let us do example number 9. What does it say? It says a manufacturer makes 2 models of an item. Okay, model 1 which amounts of 80% of the unit sales. So there are model 1 and then model 2. So a company produced 2 types of item. Model 1 has 80%, 0.8, 0.8, okay, and model 2 has 20%, 0.2% of the items in the market. So because of the defects, the manufacturer had to replace 10% of the model 1. That means from model 1, 10% are defective and then 90% are good, right? From model 2, it says, and 18% of the model 2 because of they are defective. So meaning 0.18% are defective and then 0.82% must be good here, okay? If a model is selected at random, find the probability that the item will be defective. If you pick one item from the market randomly, what is the probability that you will be picking the defective item? Either from model 1 or from model 2, it doesn't matter. So this is defective item from model 1, this is defective item from model 2. Meaning, you first pick model and then go to the defective item in the model 1, right? So what is the probability of the model 1? Look at that, probability of model 1 is 0.8 times probability of defective item in model 1 is 0.1, right? So 0.1 plus probability of model 2 is 0.2 because 20% of the item are from model 2, and the defective in model 2 is 0.18%. Probability of defective given that it is from model 2, that is that value. Now you use calculator, so it will be 0.8 times 0.1, okay? So 0.8 times 0.1 plus 0.2 times 0.18. If you do that, you'll get 0.116. 0.116. That is basically the 11.6%, right? chance that you will be picking the defective item. In other words, you can see like it is the weighted mean of the defective item, right? So 80% is the weight and the defective is 0.1, 10% are defective, and then you can think of that way too. All right, so let me stop here, and another video will be on the conditional probability.